Hello guys, welcome back to another math video on my channel. Today we have this very interesting looking math challenge to look at. It's an Olympiad question, okay? We're going to look at how to evaluate this problem on the board. But something I must say before we go ahead to solve this problem. Now, I know that we can easily bring out our calculator, any kind of calculator, to just punch in the figures and then get your answer and we are done. But this is actually not the purpose of this question. The purpose of this question is to test our knowledge of algebra. How can we interrogate this question using algebra? All right, so that is actually the purpose of this question. And like I said, this is an Olympiad, a standard Olympiad question, and it's not just enough to punch the figures into your calculator and you think you have gotten the answer. No, that is not how we're going to approach this problem. So we're going to be using algebra. So having said that, if you are coming across my channel for the first time, please consider subscribing. If you have been watching my videos and you're yet to subscribe, please do well by subscribing. So let's get started. So I'm going to put down solution. And then of course, what I'm going to do is to say let P equal to square root of 11 to the power of 4 plus 100 to the power of 4 plus 111 to the power of 4 divided by 2. So we'll go ahead and simplify this. So therefore, we have P equal to square root of 11 to the power of 4 plus 100 to the power of 4. So I'm going to rewrite 111 to give me 100 plus 11 all to the power of 4. Everything divided by 2. Now I'm going to go ahead and use substitution further. So here I'm going to say let A equal to 11 and B equal to 100. So if that's the case, this equation becomes P equal to square root of A to the power of 4 plus B to the power of 4 plus A plus B all to the power of 4, then everything divided by 2. So all of this divided by 2. So what do we do now? The next thing to do is to find the expansion for A plus B to the power of 4. Yes, I'm going to find the expansion for A plus B to the power of 4. I'm going to be using Pascal triangle, that's binomial coefficient. So let's use the Pascal triangle to obtain the coefficients for the terms of this particular algebraic identity. So we have A plus B to the power of 4. So let's find out the Pascal triangle, all right? I mean the coefficients, using Pascal's triangle to find the coefficient of the terms. So there will be a total of 5 terms, okay? So we're going to find the coefficients. So to do that, I'm going to use this method here. 1, I have my 1, okay? Then I have 1, 1. So what I'm going to do now is to add these two terms, these two numbers together, 1 plus 1, I get my 2, and then I start with a 1 again, and then another 1 here. 1 plus 2 will give me 3. 2 plus 1 will give me another 3. So I have 1, 1, okay? So next I have 1 plus 3 gives me 4. 3 plus 3, that will be 6. 3 plus 1, that will be 4. And then of course 1, 1. So that's it. So you can see there are 5 coefficients. And so like I said earlier, there will be 5 terms of this expansion, in this expansion. So how do we get it? So the first term will be A to the power of 4. All right? The expansion of this term, so the first term will be A to the power of 4. Let me do that again. So we have A plus B to the power of 4. So the first term will be, so here is the expansion, the coefficients rather. So the first term will be 1A to the power of 4 plus the second term will be 4. So what will happen is that here, the A is to the power of 4, and then the power of B will be 0. And of course, whatever you raise to the power of 0 is 1. So that is why we're having 1A to the power of 4. So for the second term, the power of A will reduce by 1 to 3. So I have A to the power of 3. And then, here, for the first term, the power of A and B was 0. So here the power of A and B will be 1. Plus, the coefficient here is 6. So the power of A will reduce by 1 now, so A squared, and then the B the power of b will increase by 1. So here it is 1, by another 1, so it's going to be 2, plus 4 to the power 4a to the power of 1, then b to the power of 3, plus the last term. The last term will have the power of a to be 0, but that of b is going to be 4. So that is the expansion for the this a plus b to the power of 4. So I'm going to take this now and substitute it into this original equation here. So it means that p will now be equal to square root of a to the power of 4 plus b to the power of 4 plus the expansion of a plus b to the power of 4. That will be a to the power of 4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed, then plus b to the power of 4. Everything divided by 2. So I'm going to collect like terms now. You can see we have like terms, a to the power of 4. We have an a to the power of 4 here, b to the power of 4, b to the power of 4. So let's bring those together. So p will now become a to the power of 4 plus a to the power of 4 will give us 2a to the power of 4 plus b to the power of 4 plus b to the power of 4 will give 2b to the power of 4. And of course, we have 6a squared b squared plus 4a cubed b plus 4ba cubed. Everything divided by 2. All right. So from here now, you can see that the numerator of the fraction under the square root sign is divisible. They are all even numbers. So I can factor out 2. So I have 2 brackets, a to the power of 4 plus b to the power of 4 plus 3a squared b squared plus 2a cubed b plus 2ab cubed, all close brackets, all divided by 2. So you can see now here that 2 and 2 will cancel out. So what do I have? So 2 and 2 will cancel out. So I'm going to have, what we're going to have will be p equal to square root of a to the power of 4 plus b to the power of 4 plus 3a squared b squared plus 2a cubed b plus 2ab cubed. So this is what we have. And this is where it gets more interesting, because we're going to be doing some kind of I'm not going to call it manipulation, but a kind of rearrangement. All right. So what I'm going to do now is to first rewrite a square as, a to the power of 4 as a squared all to the power of 2. Then the same thing with b to the power of 4, that will be b squared to the power of 2. And then I'm going to split 3a squared b squared to 2a squared b squared plus a squared b squared. And of course, we have our 2a cubed b plus 2ab cubed. I'm careful to allow this square root sign to cover all of that. Okay, so from here, I'm going to take this term. I'm going to take that. This is a perfect square. And I'm going to first rearrange it to give, I'm going to rearrange this to give a squared all squared plus 2a squared b squared plus b squared all squared, then plus we have a squared b squared plus 2a cubed b plus 2ab cubed. All right, so we have that. So from here you can see now that this particular, if I group this together, this is comparable to x squared plus 2xy plus y squared. And of course, we know that this is the same thing as x plus y squared. It's a perfect square. So what that means is that this expression here is a perfect square. And so I'm going to rewrite this using this particular identity here. So it means that P now will become square root of a squared plus b squared all squared, because here I'm taking a squared as x and then b squared as y. So we have this. Then of course we still have a squared b squared plus 2a cubed b plus 2ab cubed. All right, so we still have work to do. So what I'm going to do now is to still go ahead to rewrite this. So let me give P equal to, so I'm going to rewrite this to give me square root of a squared plus b squared all squared. Then I have a squared b squared as ab all squared plus, now I'm going to factor out 2ab from here. So I'm going to have 2ab, so that inside bracket we are going to have a squared plus b squared. Can you see that? Now the next thing now is I'm still going to go ahead and rewrite this, the whole of this. I'm going to rewrite it to look this way. P equal to square root of a squared plus b squared all squared plus 2ab bracket a squared plus b squared plus ab all squared. So this is now also a perfect square, which we can compare with x squared plus y squared, x squared plus 2xy plus y squared. And this in itself we know is equivalent to x plus y all squared. So in this case now, our x will be a squared plus b squared, and then y will be ab. Okay, yes, y will be ab. Y will be ab. So if that's the case, so this expression now will become P equal to square root of, if we use this identity here, so the whole of this now becomes a squared plus b squared, that is for x, and then for y we have ab, all of these squared. So you can see now that the whole thing has been reduced to this simple format. So if we go ahead and expand this now, it's going to lead us back to this. Okay, so, and then of course from here we can see that the square and the square root will cancel out. So it means that we have P to be equal to a squared plus b squared plus ab. So what this means is that, so we now have that P will be equal to a squared plus b squared plus ab. We know that a is equal to 11 and b equal to 100. So using this now, we can find the value of P to be 11 squared plus 100 squared plus 11 times 100. So this is 121 plus 10,000 plus 1,100. So let's add all of this together. So we have 10,000 plus 1,100 plus 121. So that will be 12211. So this will be 11,221. Therefore, P will be equal to 11,221. So, but P is actually equal to that whole expression. Therefore, square root of 11 to the power of 4 plus 100 to the power of 4 plus 111 to the power of 4 will be equal to will be equal to 11,221. So there you have it, guys. So we have come to the end of that of this challenge. So please like, share, and comment. And then, of course, don't forget, if you are here to subscribe, please subscribe, and I'll see you in my next video. But before then, there is on your screen, on the right hand side of your screen, there is my playlist. Please click on that playlist to go and watch some of the most popular math challenges on my channel, and I'll see you in my next video. Bye bye.